Is anything happening? I don't know. Okay, well, whatever. I just feel bad because people can look at these PowerPoints, but without, talking about them, all it is just letters and numbers. Oh, I forgot. One more thing I wanted to show you about the My Math Lab before we leave that idea. When you go to the chapter contents, so like this is chapter 2, section 4, I think. Like this would be chapter 2, section 1. And when you go there, you can go to watch a video presentation, and they're decent, surprisingly decent. I'll show you. And you can choose which part of it you want. Like, it just starts with
equations and solutions. Example.
It just has same kind of stuff that you'll find on the homework, same kind of stuff in the book.
Or neither. 4 minus 6 equals 2.
I mean, if you don't fall asleep.
Work this out on your own. Press play when you're ready to check your answer.
And so you can check answers. There's not like music or dancing or anything. So
the equation is
pretty boring, but you can jump ahead. You can do whatever you, and these are what's supposed to come up as the help when you're stuck on a problem too. Although I've found that doesn't really work very great on my computer. But the big deal here is that a solution is a true statement. It's an X value that we put in that makes an equation true. So we can find, okay, 5 minus 8 is not negative 4, is it? It's negative 3. That's false. 12 plus 6 really is 18. That's true. What about x plus 6 equaling 7 minus x? It depends what x is. Because x is, think of it as a note card. There's a number on the back. You don't know what it is. We can find out what it is. We can make a guess as to what it is. Sometimes people just guess until they get it. That doesn't seem very efficient, but it's something you can do. So it depends when you have an x if it's true or false. If we put a number in there that makes the equation true, x is called a solution. That's what a solution is. So that definitions is what you're going to see here. And then a bunch of these are just testing out to see if a solution works. If I put in 8 for x, is it true? 8 plus 4 equals 12. Yep. So 8 is a solution. If I put in 0 for x, it's not true. 0 plus 4 is not 12. So that's not a solution. Equations with the same solutions are called equivalence equations. So these we would just be solving for that variable. And we talked about that last time. Some people think about drawing a river down the middle. And you have to do the same thing on both sides. So for example, in this one, I would subtract 17.4 from each side. Fraction ones are always a little more interesting. But again, that's why they have that little lesson at the beginning about fractions. We would add 2/3 to each side here. We would draw a river down the middle. We want x alone, so we would add 2/3 to each side. But when we do that, 2/3 needs, so we would, let me just refresh your memory a little bit about fraction adding. If we want 5/2 plus 2/3, right? Because I would do plus 2/3 plus 2/3. So now on this side, this is a 0 pair. All I've got is x. And on this side, what needs to happen there? Do you remember? Yeah, because I've got a 2 here and a 3 here. So between those, what's the best number I'm going to multiply by to get them to the same number?
Well, you want to turn them into 6.
Does that make sense why it's 6? That's our least common multiple. Do you remember from the first day we talked about those? So I would multiply this one by 3/3 and this one by 2/2. I kind of like writing them vertically like this actually, because then I've got 15/6 and 4/6, and that's what I've got to add. So 19/6. And actually, that'll be what you put right in the computer if this was the problem on the computer. It's never asking for mixed numbers.
Okay, so when I was doing my homework, on some of them, like let's pretend that it's going to be like 16/6, and you could like make it a smaller one,
Yep.
I would get it wrong. And
Well-
sometimes they would want the bigger one, and I'm kind of
Usually the word
confused.
simplify will be in that little parentheses after it. It'll say, use simple integer or simplified fraction. And so if simplified is in there, I think that's when they want you
I
to.
feel like they always say that, or almost
Yeah, most
always.
of the time. So then, so think about how would you simplify this? What would you do?
Well, 8 over.
Because you'd
3.
say 16 and 6 have a 2 in common, so you do divided by 2 divided by 2. Is that what you're thinking?
Yeah, 8 over 3.
So 8 over 3, and then that should be correct.
Okay.
If it's not, do a screenshot. Or you can grab your phone and you can take a picture of the screen and send it to me. Because I don't know, when you send me those help requests, it doesn't always show me what you put in already.
Oh, okay.
It shows me the problem, the exact problem, but with the same numbers as you have. It doesn't show me what you put in.
Could you do this one that I'm stuck on as an example?
Oh, I would love to, and everybody would probably love to see it.
It's x plus 1/3 x equals 24.
Equals 24. Oh, that's a good one.
Yeah, that's worth it.
Yeah. So the first thing that you usually do is combine like terms, right? So here we have an x, and I know there's nothing in front of it, but what would you think of in front of it? 1. So it's like 1x plus 1/3 x. And I like to combine those, but again, I'm going to need a common denominator. This is in thirds, and this is just a whole number. So how could I write 1 so that it's in thirds? How many thirds are in 1? 3 over 3. So I might rewrite this 3/3 x plus 1/3 x equals 24.
Mhm.
And then 3/3 x plus 1/3 x is 4/3 x, right? So 4/3 x equals 24. I'm going to think about 24 as being over 1 also. So maybe some of these fractions you can think it through, like 4/3 of something is 24, but I can't think like that very good. So last time we talked a little bit about this, but this is a good time to review.
Is that the answer, or
No.
divided by 3?
This is just like 20, this is just like part of it, but we're not done yet.
Okay.
So then now we got to get x alone, right? What do we really want with x?
Okay, so
Yeah, we just want it by itself. We want to have 1x, right? So I need to multiply each side of, last time we talked about dividing by a fraction. Remember, I know I saw you singing the song. Dividing fractions, my oh my. Flip the second and multiply. So what I'm really doing on each side of this equation is dividing by 4/3. But that seems messy. So instead of dividing by 4/3, I'll flip it and multiply by 3/4. And if I do it on this side, I got to do it on this side. And so now on this side, look what happens. 3 times 4 is 12. 3 times 4 is 12. So I have 12 twelfths. And some people would cancel, because 4 over 4 is 1. 3 over 3 is 1. So I got x is all that's left over here. Great. That's what I was hoping. And then on this side, 24, like I said, I'm going to think about it as 24 over 1 for multiplying easier. So 24 times 3, and then divided by 4. Or I could think of 24 divided by 4 is 6. 6 times 3 is 18.
Instead of multiplying by that whole fraction,
Mm-hmm.
3/4,
Yep.
I instead just multiply each side by 3. Would that ever mess me up?
No,
If I just do
that's a
that?
great idea. Just to do.
Yeah, 'cause
Yep, we called it fraction busters is another. Yep, I just kind of combined 2 steps in one, but no, that's a great idea. So at this point, you said, I'll just multiply everything by 3. And then you had 4x on this side, because 3 and 3 would cancel, right? And then over here, what's 24 times 3? 75, 72, yeah. Sounds good. And then now you divide by 4. Perfect. I actually like that better. So then it's still 18, isn't it?
That's what the math lab showed me today.
Like the video? Or the step by step?
Just step by step.
Good. This way.
Yeah.
Yeah. And it's really, if you multiply by 3 and then divide by 4, it's the same thing as multiplying by 3/4. But if this is gross looking to you and you're like, why am I multiplying by fractions? I don't like it. Then I definitely like this one better. Great. All right, so there's more of those which we'll pass on. Try to move along a little. I know it's just a toss up between going over everything really super close and getting you out of here. So, and getting caught up to where because we have a test on the 7th, which is only 2 weeks away. And then I'm going to Hawaii on the 9th, which is really only a little more than that. Yes. I will send you videos. And I'll post them on my Weebly from the, no, I'm just kidding. I don't think I'll give it a thought. I don't think I'll think about pre-college algebra at all. I'm going to try not to. I will a little before it.
Yeah.
How are we doing? Reciprocals? You're just going to flip it? A reciprocal is a number. When we multiply, we end up with 1. And the beauty of that is when we're trying to solve equations, sometimes that's a quicker step. So the reciprocal of 5 we said was 1/5. The reciprocal of negative 5/4 is negative 4/5. If it's negative, we need it to be negative again so that the product is positive. So on these, they want you to just practice. They say multiplying on both sides. My inclination would be to divide each side by 6. But since they say multiply, we'll multiply by 1/6. Dividing by 6 is the same thing as multiplying by 1/6. These are all just, draw that river down and do the opposite operation. I put this one up here because people a lot of times, instead of dividing, will want to add. Like they'll say, oh, it's negative 2.1. I need to add 2.1. But what you want to do is look at what's going on with that variable. It's multiple. You can even put it in the collab like that if you want. We're going to divide because right now we're multiplying a negative number. If it was instead like negative 2.1 plus y equals 6.3. Now, since this is an addition, right, I would want to get rid of the negative 2.1. So I would do the opposite to make a 0 pair. So I would plus 2.1 on each side. But up here, do you see how these are different? Super common mistake to make to add 2.1 there, but don't. I'm going to go with Cole's method on this one. Multiply each side of that equation by 9. And once we do that, then we'll have negative y. Once I multiply each side by 9, I would have negative y. Well, that won't do. I need y all alone and positive. So I would multiply each side then by negative 1 to solve it. You can always, if ever you have a negative variable, either multiply or divide by negative 1. Same thing again here. I would multiply everything by 2, and then I'd have to divide or multiply by negative 1 for my final answer. You just have to keep it balanced. I hope that when you think about solving equations, you think about a balance in your mind. If you're going to subtract 2 from one side, you have to subtract 2 from the other side. You multiply by 7, you got to multiply both sides by 7. Here's a homework problem. Let's just try it. I printed some of these out and I thought we could move around and do them, but this one I didn't. So if you just have a piece of scratch paper, will you grab a piece of scratch paper and let's just do this one. It's so similar to these others that I don't think we'll do these. But let's do this homework one because you're bound to come across one very similar to this on your homework. So it's negative 3x minus 7x equals 70. We started out with one like this, and now and this is like the one that he asked about actually. You can see the topic listed above there, collecting like terms.
Yeah, I was having problems with that on my homework.
We're doing the right thing then, good. Okay, so jot this down. I'll try to be quiet for a second so you can try it.